We have already discussed about the vectors and the kinematics in one dimension. Now there are some cases of the kinematics in one dimension related to the graph, and we have to discuss the graphs, basically the displacement time graph and the velocity time graph. Acceleration time graph is also there. So first we will proceed with the kinematical equations. See, this equation is S equal to ut plus half at square. S equal to ut plus half at square, where S represents displacement of the particle and u represents initial velocity, a acceleration and t time. And in this equation acceleration is uniform, means its magnitude and direction both remain constant. Clear? So this is the all the terms used in this equation. Now if I consider that the particle is not accelerating, means it is moving with uniform velocity. So uniform velocity means acceleration term should be 0. Uniform velocity means velocity is not at all changing, means there will be no acceleration. So acceleration term will be 0. Then this equation reduced to simply S equal to u into t, and u remain constant. So that's why this, if we draw a graph of this equation, this will give you a straight line passing through the origin, because this axis is S, this axis is time. Just put t equal to 0, you will get S equal to 0. So it will pass through the origin and it will be a straight line, because coefficient of t will represent the slope of this straight line. You can compare it with the equation of the straight line, you know, that is y equal to mx plus c. C term is 0, so the graph will pass through the origin. You can compare this equation with this format, general format, y equal to mx plus c of the straight line. Then in that case, this m in this equation is u and c is 0. So slope of a straight line is always constant, because straight line means this angle will not change. So this will be u and this c is 0, so it passes through the origin. Because on putting x equal to 0 in this equation of a straight line, if c 0, then y will become 0. Okay? Anyone having any difficulty, you can ask. All of you, is it clear that on putting x equal to 0, y will be 0 and graph will pass through the origin and it will represent a straight line? C is some constant, suppose c is 2, it is y equal to 3x plus 2, then it's also a straight line. So in generally, instead of taking value, I write c. Okay. Now you can also check, similar to this form I can write many other form, y equal to say 3x plus 2. This one is equation of a straight line, but if c0 means this term is not there, just put x equal to 0, what you will get? Y equal to 0. So the graph will pass through the point 0, 0 means through the origin. Same format is here. So if you put t0, then s will be 0 and the graph will pass through the origin. Okay? Now, so this is the ST graph or displacement time graph for uniform velocity. Then if I consider that the initial velocity of the particle is 0, this is the first case. Now we are going to the second case. I consider that the initial velocity of the particle u equal to 0, but acceleration a not equal to 0. Acceleration constant but not 0, suppose 3 meter per second square. In this situation, this first equation reduces to s equal to half at square. Okay, s equal to half at square. Uniform acceleration means acceleration is constant. So half a is also constant. If a is constant, then half a is also constant. So we can say that in this equation s equal to some constant into t square. So if I draw a graph between s and t, which type of graph it will represent? You can assign some values. Suppose s equal to simply t square. So if t is 0, s is 0. If t is 1, s is 1. If t is 2, s will be 4. T is 3, 9. So the value of s will increase faster than the value of t. In that case, the graph will look like this, called a parabola. It is the graph of a parabola. Suppose y equal to x square. This is similar to that graph. If you put x equal to 0, y 0, x equal to 1, y 1, x 2, y 4, x 3, y 9. So the increase in y is faster than increase in x. So the graph represents a parabola. It is not a straight line. As long as y and x both are changing with the same rate, the graph will be a straight line. Okay? Now, so for the accelerated motion with initial velocity 0, graph will be a parabola. Now come to the general case. When this entire equation is there, ut plus half at square, both the term are there. So graph will be like which one? If ut part is only present, graph will be a straight line. If half at square part is only present, graph will be a parabola. If both the parts are present together. Achha, suppose you are in home. You are in home. There nearby your home, your friend, one of your friends stays, who is not willing to study at all. Okay? Whenever you start studying, your friend will come and say, come and go for a play. Don't study right now. And suppose at that time your parents are in the room, in the home. So which one will you follow? Will you go with your friend or will you stay in the home for study? So who has putting on you the dominating effect, your parents or friends? Parents. So this part is like your friend. This part is like your parents. Parents have more dominance. Power is 2. Friend has less dominance. Power is 1. So when both the factors are adding together, so which factor will be dominating? Parents. So the t square factor will be dominating. So the nature of the graph will be according to the dominating factor. Means parabola. Because only t to the power 1 represents straight line, t to the power 2 represents parabola. When t and t to the power 2 both are present, then dominating factor is t to the power 2. So the graph, behavior of the graph will be like t to the power 2. So it will be a parabola. So no need to think anything, just draw the parabola. So in general, even if initial velocity is not zero, accelerated motion is accelerated with uniform acceleration, the graph will represent a parabola. Okay. Whether the linear term in time is present or not, nature of the graph will not change. It is always guided by the highest power term, and highest power term is t square. Is it clear to everyone? So write down this part, that whenever we are drawing a graph, the nature of the graph, whenever we are drawing a graph, the nature of the graph will be dominated by the highest power term, Okay. Now, clear? Now I want to draw this third graph once more. And in this single graph, I will draw all the conditions. First condition is that this one is absent. The graph will be a straight line passing through the origin. So draw it. Now if this term is present, the graph will be a parabola. Like this, moving up. Instead of this, if this term is minus, means retardation, then in which direction the graph will bend? Downward. Like this. This is for acceleration. This is for retardation. This is for uniform velocity. Okay, so for uniform velocity, the graph will be a straight line. ST graph will be a straight line. For accelerated motion, it will be a parabola moving upward. For retardation, it will be also a parabola, but it is concave downward. So into opposite side because of the minus sign. Retardation means minus half a t square will come. Okay. Is this concept clear to anyone? If you have any doubt at any point, you can ask. T square? S versus t square we can always do, but that will be a straight line. S equal to half a t square, suppose, only ut is not present, and you plot s versus t square. Then t square is plotted in x axis and s is plotted in y axis. So it is similar to y equal to some constant into x. It will be a straight line. Okay, so this is the ST graph. Now we will come to the VT graph. for doing VT graph, the equation that we have to use is V equal to U plus AT. U plus AT. Okay. Now, in this equation, if I consider A equal to 0, first case, then we can say that V will be simply equal to U, and it is in uniform velocity. Acceleration 0 means velocity remains uniform. So the graph will be like this. Because once the velocity is u, it will not change with respect to time. So whenever be the time, the velocity remains same. So it's a horizontal line, it is a straight line horizontal to parallel to the time axis. If acceleration is 0 and we are drawing a VT graph, means V is not at all varying with time. So that is uniform velocity. Now, if acceleration is not 0, then first we consider this case, that acceleration is non-zero but initial velocity is 0. So this is V, this is T. Now in this situation, that equation reduces to V equal to AT only, because I considered U 0 and A non-zero. So it is similar to S equal to UT graph, like a straight line, because if you put T 0, you will get V 0. So the graph will pass through the origin and it will be a straight line. But this is not uniform velocity. This is a motion with uniform acceleration starting from rest. Motion with uniform acceleration starting from rest. Okay. Now, if the initial velocity is not 0, that means we want to draw the general form. Then see, the graph will start from here. It will not start from the origin. Why? If you put t equal to 0, this is velocity axis, this is time axis. If you put t equal to 0, what is the value of v? U. So if you put t equal to 0 means you are at this point, origin, the value of v in that case is equal to u. That is called the initial velocity. So this part has a length u, and this it will go as the straight line as before, because y equal to mx is a straight line, y equal to mx plus c is also a c. Non-zero means graph will not pass through the origin. That is the only difference, and since it is not passing through the origin, it will represent some initial velocity when you put t equal to 0. And if it passes through the origin, then its initial velocity is 0, means it starts from rest. Okay, have you copied all this thing? Any question you want to ask? Third one? Okay. See, if u is not 0, Then if you put t equal to 0, what will be the value of v? U. So t equal to 0 means this point. So at this point v is not 0, means v will not this graph will not intersect at the origin. So I consider here. So this is the velocity of the particle at t equal to 0, means it is called the initial velocity, and the remaining graph will be a straight line because there is no t square like term. Yes. When? At rest. When the body will be at rest. See, first case velocity time graph is a constant, that is moving with constant velocity. Bodies at rest means velocity graph will represent just like a dot. It is not at all changing the position. There is no changing, there is no movement. And if there is ST graph, then it will be a horizontal line, because position is not changing with respect to time. Third one. Which one?
That third one. You said initial velocity is not equal to 0.
Yes.
But then what if it is starting at rest over there?
Oh, if starts at rest, then the second graph will be.
Okay.
Because u0 means v equal to at, and it will cut at the origin. Okay. Okay. Now, if there is retardation, how the graph will be? This graph is moving upward, means if you calculate the slope means this tan theta of this angle made with the time axis, then it is a positive slope. Positive slope means you can consider here, you can also draw a horizontal line and take this one as theta. Then slope is defined by tan theta. Now see, in both these cases tan theta will be positive because theta lies in first quadrant, it is less than 90. So in both the cases tan theta will be positive. So this graph has a positive slope, means acceleration is positive, because slope of the velocity time graph is representing acceleration. How? Just drop a perpendicular. This is give you change in velocity. This is giving you change in time. So tan theta means delta v by delta t. Delta v by delta t means change in velocity by change in time. That is called acceleration. So slope of Vt graph equal to tan theta equal to delta v by delta t, called the acceleration. And since it is a straight line, the slope will never change, so acceleration is constant. Okay. So slope of the Vt graph means change in velocity by change in time, that is representing acceleration. And since it's a straight line, slope will not change, so acceleration remain constant. Now, if it is retardation, the graph will be like this. Velocity time. velocity time graph will be like this. See, with respect to time, velocity is going to decrease. As time increases, velocity is going to decrease. Velocity decreases means it represents retardation. Previously, as time goes on, velocity will increase, means this height will continuously increase. So that is acceleration. If it is retardation, velocity time graph will be again a straight line, because the equation is now v equal to u minus at. Okay, so with respect to time, velocity continuously decreases, and if it is one time will come, it will come to 0 if the observer sees the last point, this one. Now what will be the velocity time graph? We have learned that slope of the Vt graph equal to acceleration. Now what is the angle with this graph with the time axis? This angle, suppose theta. Now tan theta will represent acceleration, because there I defined that tan theta represents acceleration. So in that case, this one is the angle with the positive direction of the time axis, not the included angle. Remember, the angle between the positive direction of the time axis with this graph, that is taken as the angle for calculating the slope. Now tan of this angle will be equal to acceleration. Now tell me, this angle theta for this graph, is it greater than 90 degree or less than 90 degree? Greater than 90 degree, but less than 180 degree. So it lies in which quadrant? Second quadrant. And in second quadrant, which trigonometric ratio is positive? Sine. All sine, tan, cos. So in second quadrant only sine is positive, so tan will become negative. So this will give you A is negative. A negative means negative acceleration. Negative acceleration is called retardation. So this is the retardation. Positive acceleration means velocity increasing. Negative acceleration means velocity decreasing. That is called retardation. Since theta lies in the second quadrant, tan theta will become negative and it will represent retardation. What is this height in velocity axis? 10 meter per second. And what is this length? 8 seconds. So acceleration of the particle is 10 by 8 with a minus sign. With a minus sign, because it is retardation. So if you calculate acceleration, this will be 10 by 8, that is minus 5 by 4 meter per second square. Because this is the y coordinate. Y coordinate is 10. So the velocity increases from 0 to 10. So change in velocity is 10 meter per second. And this one is 8 seconds. So change in velocity by time is acceleration. And since slope is negative, means initial velocity is 10. Finally it goes to 0. Means it is moving with retardation. Okay. Y axis I plot acceleration. In x axis I plot time. And acceleration versus time graph is given a straight line which intersect the two axes at the following points. It intersects the time axis at 8 second, 0, means acceleration is 0 here at 8 second, and at t equal to 0 acceleration is 2 meter per second square. Then what is the velocity of the particle? 16. How to calculate? It is the area under the acceleration time graph. This area represents area of this triangle. You have to calculate area of this triangle. Area of the triangle is half into base into height. So base is 8, height is 2. So half into base into height means 8, and unit will be unit of velocity, that is meter per second. Achha, first write down this one. Area under acceleration time graph. Area under acceleration time graph represents velocity. Okay. And another point, area under velocity time graph. Area under velocity time graph represents displacement. Represents displacement. Okay. Now, you can have a very easy idea why it is representing velocity and why second one is representing displacement. This side is acceleration. On this side I plot time. If you find the area, then you have to multiply actually acceleration and time. Acceleration has a unit meter per second square. Time has a unit second. So one will come cancel and it will be meter per. So that is the unit of velocity. So area under acceleration time graph will represent velocity. Similarly, if you are going to velocity time graph, then one axis will be meter per second, another axis will be second. Multiplying second will cancel, you will get only meter. So that will represent displacement. Okay. So this one is acceleration time graph. So multiplying, calculating the area, I can write this length is 2, this length is 8 seconds. So area will represent, this area will represent velocity, means half into base into height, that will be 8 meter per second. Now we will discuss the other topic, that is the two-dimensional motion. There are two parts of the two-dimensional motion in NEET syllabus. One is the motion of a projectile, another is the circular motion. Only these two-dimensional motions are in the syllabus. First, we will discuss the projectile motion. Now, in projectile motion, first we will consider only two cases you have to learn. One is the ground to ground projectile, and from a height, if it is thrown horizontally, then it will fall on the ground. That projectile is included in the syllabus. The projectile thrown over an inclined plane, that is not in NEET syllabus, that is a part of the JEE syllabus. So we will not discuss that here. So first we will consider the simplest case, that suppose this one is a tower having some height y, having some height y, and we consider a stone is thrown horizontally with some velocity u. We neglect air resistance and all these things. and gravity is constant and acting vertically downward. Means this is the direction of the acceleration due to gravity. Okay. Now, the motion of the particle will be like this. So it is not going continuously along the horizontal direction because gravity pulls it downward, so the motion will be in a parabolic path and it will fall on ground after a certain distance. Now, for analyzing this motion, how to proceed? Suppose at this point we throw the particle, then we can say that after how much time it will reach to the bottom. This distance is considered to be x, this entire length. How long the particle will take to come down to the ground? Achha. If it is going towards the downward direction, it will come to the ground. Then what will be its displacement along the vertical direction? Why? Because actual displacement is this one, from this point to this point. That's a straight line. But what is the vertical displacement? Only this one. And another is horizontal displacement, that is x. Now see, vertical displacement and horizontal displacement, they are always perpendicular to each other. And earlier we studied vector resolution, where we say that if the vectors are resolved into perpendicular parts, they are independent of each other. In the last class when we discussed resolution of the vectors, we said that why we take perpendicular resolution, that x and y axis perpendicular, because then x and y are not depending on each other. So when we will discuss the vertical motion of the particle, we can forget about all the quantities which are along the x axis, means horizontal direction. Now see, in vertical direction the displacement is y when the particle will reach to the ground. Then in vertical direction, what is the velocity? Is there any velocity in vertical direction? No. U is thrown horizontally. So what is vertically downward velocity? 0. Nothing. Is there any acceleration in downward direction? Means vertically? Yes, that is g. So I will write this equation. I only use this equation, s equal to ut plus half at square, and this equation is restricted for one dimensional motion. So in a two dimensional motion, how can we apply this? We will recognize a two dimensional motion as if it is a combination of two one dimensional motion treated independently, because we consider rectangular resolution. One axis vertical, another axis horizontal, angle between them 90 degree. So no need to bother to the other axis when we are discussing the motion along one axis. That is the advantage of resolution. So we will do that. So in this case, for s, what we will write? Y is the displacement along vertical direction. So displacement along vertical direction is y. So s is replaced by y. Is there any initial velocity in the downward direction? No. So initial velocity will be 0. So ut term is already 0, plus half. Is there any acceleration in downward direction? Yes, that is g. then t square. So we get y equal to simply half g t square. This is my equation 1. Y equal to half g t square. That is equation 1. So how we come to this equation? Because along vertical direction displacement is y. There is no initial velocity along vertical direction. So we consider initial velocity along downward direction is 0. So we put u equal to 0 for the vertical motion and g is there for the vertical motion, then half gt square. Clear? So we get this equation. Now for the horizontal motion, what is the displacement in horizontal direction? X. This one. Okay. So again for horizontal motion, s is equal to x. Is there any initial velocity in horizontal direction? Yes, that is u. So ut term will be present now. But is there any acceleration in horizontal direction? No, because gravity is in vertical direction. So along its perpendicular direction, this vector has no effect. So g will be 0 and as a result this term here will become 0. So we are getting only this equation ut. So a two-dimensional motion by using the resolution of the vectors can always be splitted into two independent one-dimensional motion, such that we can use this equation for each direction separately. Okay. Now see, x and y, these are the geometric coordinate, means Cartesian coordinates, x coordinate, y coordinate, these are geometric coordinate. But is time a geometrical coordinate? No, it is called a parameter. Now see, in equation 1, y coordinate is given in terms of time. In equation 2, x coordinate is given in terms of time. Then I want to find a relation between y and x irrespective of time. Want to find an equation between y and x irrespective of time. How can we do it? See, from this equation 2, can I write t equal to x by u? Okay. Substitute this expression for t in equation 1. Okay, do it. Substitute this expression for t in equation 1. Good. So just write one more line. G by 2u square x square. So it is similar to parabola y equal to some constant into. So it will give you a parabola, this shape parabola.
So why is it g is 0 in the axis?
This is a vector.
Yes, sir.
What is this angle? 90 degree.
degrees.
So theta. So what is its component along this direction? G cos theta. So G cos 90. G cos 90 will be
0.
So a vector has no component along its perpendicular direction. So it is correct.
Put this one as mg.
Mg is the weight. Mg is the weight. But here we consider the kinematics. So we consider only acceleration.
Means we inject the mass of the.
If it has definitely mass, but then you have to write the equation of the force. here I use the kinematics relation. Kinematics equation, mass will not come and force will not come. Okay, good. See now, this is coming y equal to g by 2 u square into x square, right? What is the maximum power of y? 1. Maximum power of x? So the graph will be a parabola, curved line. Previously when we draw s equal to half at square, similarly the graph will be a parabola. Now the graph will again be a parabola. See, if you substitute this in this equation, you will get y equal to half g into x square by u square. So you can write this one as g by 2 u square into x square. Now see, this part is a constant. Maximum power of y is 1. Maximum power of other variable x is 2. So the graph will be a parabola. So whenever both the variables have maximum power 1, graph will be a straight line. Here one variable has maximum power 1, other variable has maximum power 2. So the graph will be a parabola. Same graph we have discussed earlier, s equal to half a t square. S versus t graph, half a is a constant, so that is also a parabola. So this graph will represent a parabola, and it is the graph between geometric coordinate, so the path of the motion is parabola. So now write down one problem. From a tower of height 10 meter, a particle is thrown horizontally with velocity 3 meter per second, with velocity 3 meter per second. Okay, find the distance from the foot of the tower, find the distance from the foot of the tower up to the point where the particle will hit the ground, Just identify this equation. What are given? Y is given, that is the height of the tower. G is 10, you can consider G 10. U is given, only you have to find X. Okay. Now write down another question. From a tower of height 1 meter, from a tower of height 10 meter, from a tower of height 10 meter, a particle is thrown horizontally with velocity, 10 meter per second. 10 meter per second. Find the velocity of the particle after 10 seconds. Find the velocity of the particle after 10 seconds. Why?
In 1 second it will touch the ground.
So it is not possible to calculate because the particle will touch the ground earlier. Particle will touch the ground earlier. So whenever this type of velocity calculation is given, don't jump to use v equal to u plus at for the calculation, because if you use v equal to u plus at, in this case you will get a finite value definitely for 2 dimensions, and then calculating you will get a finite value. But that will happen if the tower is floating in air, there is no ground. So it can fall indefinitely, then you can find. But here is ground. So after certain time it will reach the ground and collide with the ground. So this type of problem is very dangerous, because in this type of problem you will get 4 options. This is half, g is 10. So how much time will the particle take to reach the ground? Root 2. Root 2 means 1.41 second. It will reach the ground. So how can you calculate the velocity after 10 seconds? So this option is always in the ABCD. One of the option is this one, but if you take this one, you are wrong, because the particle hits with the ground before that time. So it is not possible to calculate the velocity of the particle after 10 seconds. So in this situation, none of this is the correct option. Suppose 4 options given, one of this is this value, one of this, 2 of this them are other values, and 4th option is none of this. So none of this is correct value, because the particle after root 2 seconds collides with the ground. So how can you calculate the velocity after 10 seconds? If it is less than root 2, then you can calculate the velocity by using this formula. Okay. So very careful from this type of question. Don't forget to check whether it is at all valid or not, because many times in mechanics this type of problems will come. Okay? Now,
Sir, can you find final velocity after 10 seconds?
can we?
Can you say
Huh.
velocity after 10 seconds in that question?
Achha, 0 cannot be said, because after collision it may bounce off. It may be at rest, may not be at rest. What is going on due to the bounce? You are facing, the stone will face some impulsive force, and that behavior is not known to us. So it is undefined actually. Achha, 2 concepts we will discuss, very primitive concept of mathematics. These are required for the calculation of the slope and all these things. Whenever we got the slope of a straight line, say vertical line, what is its slope? Means the value of tan theta. For vertical line, what is the value of the slope? Undefined or infinity? Undefined or infinity? Slope of the vertical line? Achha, can you, any one of you tell me what is the difference between infinity and undefined? Achha, suppose I give you this one, 1 by 0. What is its value? Undefined. Why not infinity? Achha, suppose this one, that is infinity or undefined? Achha, okay. Are they undefined in a similar manner? Achha, quite dissimilar. Okay. Suppose I have 10 by 2. Now you can tell me the proper answer. Okay, 5. Means 2 into 5 will give you 10. Now first I will ask you, suppose you are in a room, locked, there is no food and you are very hungry. So can you eat anything? No. Means your hunger will not, your hunger will remain staying with you. You cannot get any food. Next thing is that you are in a room where so many buffets are arranged. Biryani, fried rice, luchi, all these things, continental, dessert, all these things are there. And suppose all of the dishes are you like too much. Now the situation is that I have to eat the biryani first. No, I have to eat the chicken first. No, I have to eat the dessert first. Time goes on and you are still hungry. You are not eating anything. You are roaming here and there, cannot decide which one to eat first. So in both the cases, you are hungry. See the situation. Which number can we put here? Which multiplied by 0 will produce 1? Is there any number? First case, you are inside a room and no food is there. Second case, I can write 0. I can write 1, 2, 3, 1 by 4, root 2, minus 3, pi, root over of minus 5, all this, the number will not end. Means like food will not end, but you cannot decide which one to take first. So first one, there is nothing, that's why it is undefined. Second one, there is everything, there is no unique choice. So that's why it is also undefined. Now the slope of a straight line which is perpendicular, someone can say its slope is plus infinity. Some other people can say its slope is minus infinity. So which one is the unique choice? No unique choice. So it is undefined. So many times in the physics, when this type of situation will come, student write infinity. But infinity is not the correct word in that situation, it is undefined the correct word. Okay. Suppose this is a horizontal ground and a stone is projected from this point like this. Its initial velocity is u, makes an angle theta with the horizontal direction, right? Makes an angle theta with the horizontal direction. Now it is a case of two-dimensional motion. How do you know that it is a case of two-dimensional motion? More fundamentally, any motion is two-dimensional. How can you explain that this is two-dimensional motion? This cannot be a one-dimensional motion. See, because some projectile is thrown. So to locate the position of the particle at any instant of time, how many coordinate values you require? X coordinate, Y coordinate. So 2. Since 2 coordinates are required, it is two-dimensional. Can the projectile like this can move like this and then again fall? No. In that case, it will be a three-dimensional motion. But projectile motion occurring in a single plane. That's why it is 2 coordinates are required to describe the position of the particle in projectile motion at any time. So it is called a two-dimensional motion. Clear? Now, so other coordinate, we obviously choose this one as the vertical coordinate, because oblique coordinate we will never choose to complicate our life. So this one is my x coordinate, this one is my y coordinate. Okay? Now, this is the position of the particle P, denoted by x comma y. This is the origin, whose coordinate is taken as 0 comma 0. Now, what is the x? In which direction the acceleration acts? Downward direction. Downward. Okay. So in downward direction the acceleration acts. Now let us consider from point O, particle will come to point P in certain time. Let us consider that time is t, in which particle travels from point O to point P. Okay. Now I drop a perpendicular over here such that this displacement is x and this vertical displacement is y. That is the x coordinate and y coordinate of the particle. This is x, this is y. So along horizontal direction the projectile is displaced in time t by an amount x, and in vertical direction it is displaced by an amount y in time t. Now check. G is vertically down, but U is oblique to both the axes. It is not along a particular axis. We want to describe this motion by two one-dimensional motions. One is along x-axis and another is along y-axis. So which vector has to be resolved, u or g? U in this case, because g is already along negative y-axis, so no need to resolve g further. we will only resolve u. So one component of u is along this direction, that is called u cos theta. Another component of u is along this direction, that is u sin theta. Okay. Now we will stick to this equation s equal to ut plus half at square for writing the equation of displacement in each direction. Okay. Now what is the x component of displacement? X component of displacement in the diagram, x, small x, that is denoted by small x, the coordinate of x coordinate of p. So that is, in place of s I will write x. What is the horizon x component of velocity? U cos theta. So in place of u, you will write u cos theta for x coordinate multiplied by t. What is the acceleration in x direction? Nothing. G is in y direction, downward. So G has no effect on the horizontal motion. So there is no acceleration along x direction. So write down, there is no acceleration due to gravity in horizontal direction, because y G is completely vertically downward, so it has no effect along its perpendicular direction. So the displacement equation is complete, because a is 0 for x coordinate, x direction, so half at square will be 0. So we get x equal to u cos theta into t. So this is similar to the part s equal to ut, only this part is absent. So we can think of that this velocity along x axis will never change, means motion along horizontal direction is uniform velocity. Motion along horizontal direction is uniform velocity, because there is no factor to change u cos theta, because G is absent. Acceleration can only change the velocity, but acceleration in x direction is absent. So write down, motion along x axis for the projectile, motion along x axis for the projectile is uniform velocity. So initially we have a feeling that entire motion is accelerated by gravity, but now we can split it into two parts and think of it as if one part is uniform velocity and other part is only accelerated by gravity. Okay. Now we will go for the vertical displacement. What is vertical displacement? Y. This will be equal to, what will be the initial velocity in vertical direction? U sin theta. So in place of u, I will write u sin theta into t as before, plus half at square. But what is a? G. In which direction? So minus g. It will be minus half g t square. Minus half g t square. Okay. So equations are complete. So two equations I got, one for horizontal displacement, another for vertical displacement. Now see, again the same situation comes, though the equations are little bit complicated than the previous problem of horizontal projectile. X coordinate is given in terms of time, y coordinate is also given in terms of time. X and y are geometric coordinate, but time is the parameter. So if we try to find the equation of trajectory, means relation between x and y irrespective of time, then we have to eliminate time. How to eliminate time? From first equation, write t equal to x by u cos theta and substitute it in equation 2. Do it. From the first equation we can write t equal to x by u cos theta, then substitute it in equation 2 in place of t, and you will get the equation of trajectory. Okay, so it will come y equal to tan theta into x minus gx square by 2u square cos square theta. This one, tan theta into x minus gx square by 2u square cos square theta. I write the final form just whenever you are studying for the first studying, then just put the values and calculate it at your own hand. Then you can remember it for all the time. One value is obviously t equal to 0, but that is not our answer of t at this point, because particle will take some time, non-zero time, to reach up to this point. So I can cancel one t by saying that t not equal to 0 for this particular point. Clear? Then this t is coming 2u sin theta by g. 2u sin theta, this 2 multiplied here and g is divided here. So it will be 2u sin theta by g. That is the equation for time of flight. So generally we write it in capital T form. Capital T equal to 2u sin theta by g. Write it time of flight. During this entire flight, the velocity component u cos theta pushes the particle along the horizontal direction. Entire time of flight, u cos theta is there, it pushed the particle in horizontal direction. That's why the particle will fall after a certain distance. So that horizontal distance can be calculated by the calculation of the x coordinate. Okay. During the entire motion, u cos theta velocity will be in horizontal direction, so it will push the particle along the x-axis. So it will not fall at that same point, it will fall at some distance. That is called the horizontal range of the projectile. Clear? Then how to find range? Just substitute this value of time of flight in equation 1. In equation 1 means at that time how much horizontal distance is covered by the particle. So how to calculate this? I will calculate it here. So in place of x, now I will write capital R, that is the range. This will be u cos theta into the time of flight, that is 2u sin theta by g. What is coming? range equal to u square 2 sin theta cos theta, 2 sin 2 theta by g, because there is a trigonometric relation that 2 sin theta cos theta is equal to sin 2 theta for multiple angle in trigonometry. So this one will be u square sin 2 theta by g. Clear? Now suppose u is given, g is given fixed, then at which angle you have to throw such that it will cross maximum horizontal range? In that formula sin 2 theta must be maximum. So what is the maximum value of sine of any angle? +1. So sin 2 theta should be +1 for maximum distance covering. Sin 2 theta +1 means theta equal to 45 degree. Because when sin 2 theta is maximum, then range will be maximum for a given velocity. So write down, for a given value of u, for a given value of u, range will be maximum, range will be maximum if sin 2 theta will be maximum. Okay. So what is maximum value of sin theta? Sin 2 theta +1 means 2 theta equal to 90 degree, means theta equal to 45 degree. So calculate this one, that R max equal to R max will occur if sin 2 theta equal to +1 means theta equal to 45 degree. Okay, 2 theta 90, theta 45. Now write down one problem. Two particles are projected with same speed 10 meter per second. Two particles are projected with same speed 10 meter per second at angles 30 degree and 60 degree, at angles 30 degree and 60 degree respectively, with horizontal. Okay, calculate their ranges, calculate their ranges. Acceleration due to gravity is 10 meter per second square. Calculate their ranges. One is thrown at an angle 30 degree, second one is thrown at an angle 60 degree from the same point. So for you have to use the formula for range. First one is theta equal to 30 degree, next for theta equal to 60 degree. Value of u given, g given. Calculate. Sine 120 root 3 by 2. Why they have the same range? Because angles are complementary to each other. For all complementary angles, range will be same. See, if you calculate the range for the two cases, it will come equal. Why equal? Because the angles are given complementary to each other, 30 and 60. So for all complementary angles, range will remain same. Now we can find it from the general relation also. See, what is the formula for range? When it is thrown at an angle theta with a horizontal, u square sine 2 theta by g. Suppose we throw another particle with same velocity but angle 90 minus theta with respect to the horizontal, means complementary angle to this one, then calculate the range. The formula will be u square sine 2 into 90 minus theta divided by g. I considered it is r prime. Okay, so if one stone, previously one stone is thrown at 30, another is 60. 60 means 90 minus 30. So I consider one is thrown at an angle theta and deriving that formula. Then I am calculating if some stone is thrown at an angle 90 minus theta. Then it will become u square sine 2 into 90 minus 2 theta divided by g. Sine 2 into 90 minus 2 theta will be in which quadrant? It is in 180 is in second, 180 minus 2 theta will be in second quadrant. In second quadrant, sine is positive. So it will become u square sine 2 theta by g again. So the formula will not at all change. So the range will come in same. R and R prime will be same. So that's why when I have given 30 degree and 60 degree, these are complementary, range is coming same. The same thing happened for 20 degree, 70 degree, 40 degree, 50 degree. Whenever the angles are complementary to each other, range will become equal. Okay? Any question from anyone? Any doubt? Any question? Okay. Now, the third thing that I have to calculate, I will erase this portion. See, so coming up to this point, how much time is taken? Capital T. Achha, now see, above the topmost point, this parabola this vertical line, parabola is exactly symmetric. So can I say that how much time the particle will take? The time the particle will take to come to the top will be equal to the time the particle come from to this point from the top. Means time of ascent to the top equal to time of descent from the top to the ground again. That's why the parabola, because the parabola is symmetric about this vertical line. Okay. Means if total time is capital T, then we can say that in time t by 2 it will reach to the topmost point. In time t by 2 the particle will reach to the topmost point. Then what is the y coordinate equation at the y coordinate equation of the particle? Equation 2. Then in that equation, if I put small t equal to half of the time of light, then we will get the y coordinate equation for that time, that is the maximum height of the projectile. This is the equation for y coordinate related to time. If I put t time equal to half of the time of light, then what will be the y coordinate? Up to the topmost point, then that is the maximum height. So if in equation 2 I put small t equal to capital T by 2, then y will be equal to maximum height h, this one. Okay. Now you know the value of capital T. So then what will be the value of t by 2? Just check. Capital T is u sin theta by g. Then t by 2, capital T by 2 will be u sin theta by g only, because capital T equal to 2u sin theta by g. Then capital T divided by 2, that will be u sin theta by g only. Substitute that value here and calculate the value of y, then it will be maximum height. Yes.
This is equal to u sin theta by g, so why not cos theta?
Oh. What is time of flight? Which one? See. Where? Which one?
So why is not cos theta?
Why it is not cos theta? Because it is not coming from the calculation of the time of flight. What you have got in time of flight calculation? 2u sin theta by g. How it is coming? I derived it. You haven't written that?
So because the markers still for light.
Oh, someone written that. Check. Okay. See. Equation for y coordinate is 0 here. So again, when it will touch the ground,
So for even for x coordinate, so
x coordinate both 0. But here x coordinate is non-zero.
it's coming down. So
Coming down, but x coordinate is this one. This length is not 0. So that length is denoted by range. And y coordinate at this point is again 0. So in the equation for y coordinate I put 0. So how many values of t will come? 2. One value of t definitely 0 by taking t common. So that will give you this point. So when it is thrown, t equal to 0. The other value of t is the value when the particle will reach the ground again. So that value is coming 2u sin theta by, after solving this one is coming. Now, so this one is the total time during which the particle is in flight. So it is the time of flight, that is coming 2u sin theta by g. Now, in how much time it will be at the top? Half of the time, because the path is exactly symmetric. So t by 2, at time t by 2, the particle will be at the top. So at that point, what is the y coordinate? This height. That is called the maximum height of the projectile. So how to find that? You have the equation of the y coordinate, u sin theta into t minus half g t square. Now in this equation, what value of t should we put to find this one? T by 2. But the value of t is known to us. So t by 2 means u sin theta by. Now you substitute this value over here to find the formula for maximum height. What is coming? Y equal to u sin theta into t by 2. T by 2 means u sin theta by g minus half g t square, means u square sin square theta by g square. So it will be u square sin square theta by g minus u square sin square theta by 2g. Subtract this 2, it will be u square sin square theta by, that is the maximum height formula. Correct. U square sin square theta. Good. Calculated? U square sin square theta by g. Value of t should you have to put c. Y equal to what? This one. So value of t by 2. What is the value of t by 2? T is known. Use 2u sin theta by. So t by 2 will be u sin theta by. Just substitute this value over here. So y equal to u sin theta into u sin theta by g minus half g t square, means u square sin square theta by g square. So 1g will cancel. So first term will be u square sin square theta by g minus u square sin square theta by 2g. So subtraction will give you u square sin square theta by u square sin square theta by 2g. Correct. Is it coming? No. See, t by 2. When time is equal to t by 2, particle will reach to the top height, maximum height. So what is t by 2? T is known. What is t? 2u sin theta by g. So t by 2 will be u sin theta by. So write it. Now put these values in the equation for t. So it will be y equal to u sin theta. Now in place of t, what will put this value? That is u sin theta by g minus half g, this time square, that is u square sin square theta by 2g, sorry, g square. G square. This 1g will cancel. Then this term will be u square sin square theta by g minus u square sin square theta by 2g. Subtract this 2. you will get u square sine square theta. This is the formula for maximum height. Then we write it capital H. Understand?
Sir. This t is equal to t by 2, right? So
T by 2. Now what is T? 2u sin theta by g. So T by into 2 by 2. So this 2 will cancel. See, A by B is something divided by C. So A by B into 1 by C. How it will go up? See, small t equal to t by 2 when then the particle will reach to the topmost point, and at that point the y coordinate is equal to the maximum height. So in place of capital T you have to put the value of capital T, that is 2u sin theta by g, then it is divided by 2. So it will become u sin theta by g, then y will be equal to h. Then equation for y coordinate is there. So if I put t equal to this value, then y should be h. So I write for y h equal to u sin theta. In place of t you have to write u sin theta by g, that is the half of the time of flight, minus half g t square, that is u square sin square theta by g square, right? Then 1g will cancel, so you will get u square sin square theta by g minus u square sin square theta by 2g, and this will become u square sin square theta by 2g. So this is the formula for maximum height attained by a projectile. U square sin square theta by 2g. Okay? For this calculation of the maximum height, you have to put the time in y coordinate equation, that is in equation 2 equal to half of the time of flight, because at half of the time of flight particle is at the topmost point. Achha. One crucial point, at the topmost point velocity of the projectile is along the horizontal direction. It has no vertical velocity, because vertical velocity due to gravity will be 0 at the topmost point, because gravity is acting as a retarding agent up to the topmost point. So it will decrease the vertical component of velocity u sin theta. So at the top there will be no vertical velocity, only velocity is in the horizontal direction, that is u cos theta, and after that again the particle will come down, then again vertically downward velocity will generate because of the gravity. So if I ask you what is the minimum speed at which point the projectile has its minimum speed, that is at the highest point. Speed is minimum at the highest point, write it. At the topmost point, velocity vector of a projectile is horizontal, isn't it? It is actually an MCQ problem. No calculation is required at all. Just you have to think about it properly. Acha, this is a problem of which topic? Not conservation of momentum. Newton's law. See, first, according to the construction of the problem, it may give you a feel that it is a problem of the projectile motion and too many things has to be calculated. But this is actually a problem of Newton's law, second law, and you can write the answer directly without calculating anything. The answer will be this one. Baba,eki. M1 plus M2 into G into T. This is the answer. Now can you explain how? Okay, first projectile is like this. Suppose second projectile is like this. It is given after time t, velocities are v1 and v2, and that time is less than time of light, means the particle not reaching the ground yet. So it may be somewhere, anywhere. Here. What is the force on the particle? Only gravity. In which direction? What is the force on this particle? So what is the total force on both the particle? m1g plus how much time, after how much time this velocity is given? T. Force into time is impulse. Impulse means change in, that is the change in momentum. Force into time is impulse. Impulse means change in momentum. And this force is only along the downward direction. There is no horizontal force, nothing. So change in total force into time will give you the change in momentum. And in this quantity, it is asked to calculate the magnitude of change in momentum. That's why only the force multiplied by time. Now, why it is given in the problem that t is less than time of flight? Because if it is greater than time of flight, then the particle will collide with the ground and other forces will come due to collision. Then you cannot apply this formula because the direction of force and all these things will change. But as long as it is not colliding with the ground, it is in air, the force due to gravity is always vertically downward. So its direction is fixed. So you can simply add the two forces, m1g plus m2g. No need to take the vectors or all these other things. So if you are going through the construction of the problem, it seems it's a projectile motion problem, it is very complicated, so many things are given, but actually it is a direct application of the Newton's law, nothing is required. All those theta, all these things are only to, these are the only googlies. Okay. You understand the concept of this problem? Now write down water is coming out from a sprinkle. Water is coming out from a sprinkle with velocity, with speed 10 meter per second. Find the maximum area that it can wait, WET, that it can wait. Find the maximum area that it can wait. Acceleration due to gravity is 10 meter per second square. Sprinkle means water is coming like this. It has the speed 10 meter per second. G is 10 meter per second square. Then you have to find the maximum area that it can wait. Because from sprinkle water is flowing in all possible direction, coming out in all possible direction, and in a single hit they will behave like projectile. And in a single hit, how much area they can wait, that you have to calculate. Achha, can you calculate the maximum range of this projectile motion? Of course. What is the range formula? U square sine 2 theta by G. And maximum range means at an angle 45 degree. Then sine 2 theta will be 1. So I will calculate the maximum range. R max. That is equal to U square by G. U square by G, because range is U square sine square theta, U square sine 2 theta by G. For maximum range, sine 2 theta should be 1. So it will be U square by G only. Now, what is its value? 10 into 10 divided by 10, that is 10 meter. Now see the situation. From this sprinkle, water will move in this direction, in this direction, in this direction, in this direction. So the maximum up to which it can reach, R max, that is at 45 degrees, its value is 10 meter. So how much maximum area it can wait? Pi r square. So pi into R max is the radius, and then calculate pi r square. So the maximum area in which this water can reach. Because in a particular direction, from this it can reach up to a maximum range of 10 meter. Then consider the circle, having this one as the radius. So then it will be pi r square. So maximum area that it can wait, A max, that will be pi into R max is the now the radius, its square. So it will be 100 pi square meter square. 100 pi square meter. Oh, sorry, 100 pi meter square. হ্যাঁ। In one direction it can reach maximum up to 10 meter. Then in all such directions sprinkles water will coming out. So it will reach pi into r square area. Okay. So frequently this type of question can come in NEET, because these are not that much difficult question. Small calculations are required for this. So these are the almost probable questions in NEET. Okay, all of you understand this one? Another type of question comes, that is the calculation of the radius of curvature. Radius of curvature means if you have any curve and you are taking a small part of the curve, okay, you can consider that small part is a part of a circle and construct the radius of this, calculate the radius of circle, that circle. That is called the radius of curvature. Now if it is a circle and you are calculating radius of curvature at different point of the circle, it will always give you the same value of the radius, because circle means it has a fixed radius. But if for a parabola we want to find radius of curvature at different points, then it will give you different value of the radius at different points, because it is not a circle. You are deliberately trying to express it as a circle near small points, segmenting it into small parts. So at different points the curvatures are different, not equal, so it is not a proper circle, so radius will be different. Now for some cases in projectile motion radius of curvature is given to calculate. Then how? This one is the projectile. Suppose it is said that calculate the radius of curvature at the topmost, near the topmost point, means this point. Now think of it, if you consider this part, it is a part of a parabola. Can we consider this entire projectile is a part of a circle? No, because equation of parabola and equation of a circle are always different, so we cannot say. But if I say that this small part is a part of a circle, can you disagree that much? No, it almost looks same, because in that small length you cannot distinguish between a parabola and a circle, and the small part of the length can be either treated as a length of a parabola or as a part of a circle. Then that circle has some center, and up to this distance is called the radius of curvature. This is the concept of radius of curvature. Clear? Now if we consider that large part, I cannot consider it is a length of a circle. But if it is a very small part of the parabola, then we can consider that it is almost an arc of a circle. Then that circle has some center, then up to that distance is called the radius of curvature. Okay. Now, in this particular problem, if it is given that it is thrown with a velocity u and this angle is theta, then find the radius of curvature. How to find the radius of curvature? You have these values u and theta, and acceleration due to gravity is g. Vertically downward. Now tell me, what is the velocity of the projectile at the topmost point? U cos theta. What is its direction? Horizontal at the topmost point, because there is no vertical part. Let it be V, and we write V equal to u cos theta. Fine. Now, what is the force acting at that point, topmost point, on the particle? mg, because entire projectile motion is happened due to gravity. So gravitational force at the topmost point is also mg. Then what is the acceleration due to gravity at the topmost point? mg by m, that is g. Acceleration due to gravity at the topmost point is also g. So what is the direction of that g? Towards, तो दारू ही देखा जाए ना, g. So what is the direction angle between acceleration vector and g velocity vector at this topmost point? They are how much angle? Acceleration and v. Angle is 180, 90. Angle is 90 degree because acceleration vector is along radius and velocity vector is along tangent to the path. So 90 degree. This type of acceleration is called, you read it in class 11, circular motion, centripetal acceleration. Centripetal acceleration. When acceleration is towards center, it is termed as centripetal acceleration. What is the form of centripetal acceleration? V square by r, radius. So write down, forget this. Centripetal acceleration, magnitude of centripetal acceleration is V square by r, write it. Magnitude of centripetal acceleration is V square by r and it is directed towards center of the circle. Magnitude of centripetal acceleration is V square by r and it is directed towards the center of the circle. Okay. So whenever you will read circular motion, keep this in mind. Now, which acceleration is towards center here? G. So G can be written as V square by r, because form of centripetal acceleration is V square by r. Centripetal acceleration means an acceleration towards center of the circle, and here the acceleration due to gravity is towards the center of the circle. So gravity is behaving like centripetal acceleration. Okay. So we write G equal to V square by r. Now what is V? Put it. So G will be equal to u square cos square theta by r. So what is r? That is the value of the radius of curvature. u square cos square theta by g at the topmost point, not at other point. Other point, suppose here we can calculate, but that is not so easy and it will not come in NEET exam at all. Only the topmost point, radius of curvature. This, if you remember this formula, you can solve the problem directly. Other points we can also calculate, but that is a part of the JEE syllabus. Okay. Now suppose u is given 10, theta is given 60 degree, g is given 10, then you can find a proper value of the radius of curvature for the problem. So what we have to do? Whenever it is said that you have to calculate the radius of curvature near the topmost point, just construct a small circle at the topmost point and consider that the part of the parabola and part of the circle are so small that you cannot distinguish it from any particular curve. Means it can be a part of a circle, it can be a part of a parabola. In that case, that circle has some radius which is called the radius of curvature. Then at the topmost point we know that velocity is horizontal, then means it is tangential to this circle at the topmost point, then it is perpendicular to the radius, so that velocity is taken as the tangential velocity. And we know that in case of a circular motion, there is an acceleration towards the center of the circle called the centripetal acceleration. Its magnitude is v square by r, and here only force that is acting on the particle to produce the acceleration is gravity. So we equate v square by r as the acceleration due to gravity. Then from that we can find the value of r. Okay. Done? From the next class we will start the Newton's laws of motion and all these things, because that is the main part of the mechanics chapter, and I think you have some familiarity with the Newton's law and all these things. Circular motion is another part of the kinematics, two-dimensional uniform circular motion, but that we will discuss after discussing Newton's law, because otherwise we have to discuss only the kinematics portion, we cannot go into the dynamics. In circular motion there is many dynamical problem like banking of roads and all these things that will be discussed, and for those discussion we require the Newton's law. So first we will discuss Newton's law and then go to the circular motion, friction, all these things. Meanwhile, I want to ask you some questions regarding Newton's law. Okay, one or two questions we have already discussed. First one is the concept of the inertial frame. Without inertial frame we cannot discuss Newton's law. Newton's laws are valid only in inertial frame. Now what is a proper definition of an inertial frame? Velocity 0 or with respect to which we measure this velocity? Because velocity, all these things are relative concepts in mechanics. Rest and motions all are relative. So velocity is also relative. Means a car is moving with a certain velocity and another car is moving along the same direction with same velocity. So with respect to first car, second car appears to be at rest. So rest and motions are relative. So velocity is also relative. Now if I say that inertial frame is one which has either at rest or moving with uniform velocity, then the natural question will come, with respect to which you are saying that velocity is 0 or velocity is constant. Then I have to say that there is some inertial frame, and with respect to this inertial frame, the new frame is either at rest or moving with uniform velocity. So this frame is also inertial. But that is a very vague definition, because what we are going to define? Inertial frame. Now I am saying that there is some inertial frame with respect to which this one is at rest or moving with uniform velocity, so this is also inertial. So who will guarantee that your earlier frame is inertial? You will say, before that there is another inertial frame, and with respect to that, that frame is at rest or motion, so that is inertial. Now with respect to that, this frame is rest or uniform velocity, so this is inertial. And then someone will, who said that your first frame is inertial? Well, okay, before that I will consider another frame. Before that I will consider another frame. And in this way, it is actually a circular argument. Circular argument means you cannot come out of that. So what is the possible outcome? So how to define, how an observer define inertial frame? He will say that only one line.
Observer must be at rest.
It may be in uniform velocity. He will say only one thing, the frame in which Newton's first law is true. That is the definition of an inertial frame. The frame in which Newton's first law is true means the body at rest will remain at rest and body in motion will remain in uniform velocity unless external force acts. So that is the definition of the inertial frame. So Newton's first law is called law of inertia. And another thing, you have studied this one. Mass is a measure of inertia. Because if the mass of the object increases, then its inertia will also increase. Because I can move this marker by a little bit of force, because it has less mass. But if I apply the same force on this table, will it move? No, it requires more force, because inertia is more, because mass is more. Suppose a cycle is moving towards you. You can hold the handle to stop the cycle by applying some force. Suppose a truck is moving towards you. Can you stop the truck with that force? No. Why? Because its mass more, so inertia of motion is more. So inertia of rest, inertia of motion, both are more when mass will be more. So mass is a measure of inertia. So if mass is a fundamental property of the body, then inertia is also a fundamental property of the body. So since there is no other object in the universe, you cannot say it is at rest or it is in motion. So how can you talk about its inertia of rest or inertia of motion? You cannot say anything. So at least one more mass should be present in that universe, such that you can say this is at rest or this is in motion with respect to that, and now the concept of inertia of rest and inertia of motion comes. So inertia is a property of a body only when there is some other object present. So can it be a fundamental property, or depending on the presence of that second object? Depending on the presence of the second object, so it cannot be fundamental. Mass is fundamental, because this body has some mass that does not depend on whether the other bodies have mass or not. But inertia truly depends whether other bodies have mass or not and other bodies are present or not. Clear? So most of the time in the book it is written that inertia is an intrinsic property. No, inertia is not an intrinsic property or the fundamental property. Mass is only fundamental. Inertia is again a relative property depending on the presence of the other mass. Clear? So Newton's law, many places Newton's law have some grey ideas, and these are one such ideas of the Newton's law. These are very crucial ideas because sometimes conceptual question can come. Which one is a fundamental property? Mass is given, inertia is given, some other properties are given, and you have to tick one of the answer. If one option is that mass and inertia both are intrinsic, you tick that one, and that will be wrong. Clear?